All right, good evening. This is Algebra 1, Lesson 3.1, Solving Literal Equations. 3.1, Solving Literal Equations. All right, when you look at a literal equation, sometimes all of the variables can get a student concerned. Don't allow that to happen. Look, we're just solving an equation, which means what? We're going to isolate the variable. So you're looking to isolate the variable. Right? In this case, it's just the variable that you're solving for. But that's what we're doing. We're going to isolate the variable. It just so happens that there's all kinds of variables involved, but that's okay. You're going to isolate the variable. And how are you going to do that? The same way we have in the past. You're going to move things added to the variable by adding their opposite. You're going to move things multiplied times the variable by multiplying both sides by the reciprocal. All right, here's our first example. Let's do PV, that's capital P, capital V, equals N, capital R, capital T. This is actually a physics formula. It's the pressure times the volume equals the number of moles times a constant times the temperature. I know you don't know what that means. That's okay. It doesn't mean anything to you, and that's fine. But this is an actual formula. And they'll tell you what they want you to solve for. Now, if you look at this formula, we could solve for the pressure. We could solve for the volume. We could solve for the number of moles. We could solve for the constant, or we could solve for the temperature. So you could solve for any of the 5 variables. The reality is they'll tell us which one to solve for, and that's the one we're going to isolate. So in this one, let's solve for volume. Solve for V. Okay. So I'm going to take my red here. I'm going to circle my volume. Hey, that's the variable we're solving for. And again, you're thinking about an equation. You got a left side, you got a right side. Hey, what's on the same side as the variable? The pressure. What do I have to move? The pressure. Everything else is on the other side. It's going to stay on the other side. Don't need to be concerned about it. Hey, how am I going to move that pressure? Things multiply times the variable. You move by multiplying by the reciprocal. We can do the shortcut. Let's divide the left-hand side by pressure. Let's divide the right-hand side by pressure. Look at pressures divide out on the left, leaving only the volume. Hey, we've isolated volume. What's the other side? nRT divided by P. And that's it. We're done. We are rolling along, and that's all we need to do in this problem. Solving for the volume. Okay. What if we took this exact same formula, and what if now we said solve for, let's go for temperature. Solve for T. Okay, well that's no big deal. I'm going to rewrite the formula. PV equals nRT. And this time now we're trying to isolate the temperature. No problem, right? Things multiplied times the variable, you move by multiplying by the reciprocal. Again, in this situation, we can use the shortcut, and we'll divide by nR. What we do to one side, we do the exact same thing to the other side. On the left now, we have isolated our temperature. We've got it all by itself. What's the left side? PV over nR. And we have now solved this equation for T. Don't let the fact that you've got a bunch of variables scare you off. These can be easy. Let's do another one. This is an important formula. We're going to deal with it a lot this year. Y equals mx plus b. Y equals mx plus b. The m is the slope of a line, and the b is the y-intercept. And we'll deal with this a lot. We'll get there. And that doesn't mean a whole lot to you right now, and that's okay, but it will in just a little bit. All right, so there's a couple things you can solve for. Again, they're going to tell you what they want you to solve for. In this one, we're going to solve for m, which is the slope. So we're going to solve for m. So I'm just going to circle my variable. So again, you're looking at this, and you're thinking left side and right side. Okay, so I have to get the stuff on the right to the left, leaving the m, right? We want to leave that m all by itself. So what do I have to move? Well, I've got to move the x, and I've got to move the b, right? That's what's got to move. All right, so in this situation, Oops, sorry about that. Let's get rid of that. So in this situation, as we try to isolate the m, we have something multiplied times the variable, right? The x is multiplied times the m, and we also have something added times the variable. So let me ask you this question. When things are both added to and multiplied times the variable, what do you move first? And hopefully in your brain you said, I move things added. And how do you move things added? Add their opposite. So we're just going to add a negative b to the right-hand side to move it to the left. What I do to the one side, I have to do to the other side. Okay, if you'll look right here, you can't add a y and a negative b. They don't add. So that simply remains y minus b equals mx. And look, we're almost there. Now I need to move the x. How do you move things multiplied times a variable? By multiplying both sides by the reciprocal. Again, it's easiest to use the shortcut here. We'll just divide both sides by x. It's going to cause the x's on the left to divide out, leaving the m all by itself. I'm sorry, on the right, leaving the m all by itself. And so now we end up on the left, y minus b over x. And that's it. We solved this literal equation. Okay, don't let them scare you. Don't let them scare you. Let's do another one. Number 3. How about this? Capital P equals 2L, lowercase l, plus 2W, lowercase w. This is the perimeter formula for a rectangle. So perimeter of a rectangle is 2 times the length plus 2 times the width. And again, they're going to tell you what to solve for. It could be anything. Let's solve for W. Solve for the width. So again, you're going to take a look at the formula. You're going to locate that variable. It's right there. Okay, I've got to now solve for the width. How am I going to do that? I'm going to move everything from this right side over to the left side, right? That means I've got to move the 2L, and that means I've got to move that 2. What do you do when things are both added to and multiplied times the variable? You move things added first, right? How do you move them? Add their opposite. So we're going to add a negative 2L to both sides. So I added that to the right-hand side of the equal sign. I'm going to add that to the left-hand side of the equal sign. So now we end up with P minus 2L. Again, you can't add a P and a 2L. Equals 2W. And you see, I mean, we're right back almost where we were before. Now I got to move the 2. How do I move the 2? Things multiply times the variable. I move by multiplying both sides by the reciprocal, or I can use the shortcut. I'm going to divide by 2. Those 2's divide out. And now I'm left with P minus 2L over 2 equals W. Now I want you to look at this. We have a 2 here and a 2 here. Can I divide those 2's out? I hope your answer is no. All right, no, I can't divide those 2's out. Say I can't divide them out? No, I'll give you an analogy here. Let's look at something similar. If I had 8 minus 2 times 3 over 2, okay? 8 minus 2 times 3 over 2. All right, 2 times 3 is 6, right? And 8 minus 6 is 2, and 2 over 2 is 1. We know the value of this thing is 1. Okay, I just solved it like you normally would using the order of operations. Okay, so it's 1. So, are you going to get 1 if you do this? No, you're going to get 8 minus 3, and that's 5, and 5 doesn't equal 1. No, you can't cross those 2's out, right? Can't cross those out. This is our final answer. P minus 2L over 2 equals W. Let's do another one. Literal equations. Don't let all the variables scare you. All right, how about this? Area of a triangle. Again, you know me, I like to put the little subscripts on our formulas. Helps our brain. And do you remember the formula for area of a triangle? Give you a second to think of it. Area of a triangle. All right, hopefully you thought 1/2 base times the height, 1/2 BH. 1/2 BH. All right, let's solve this for height. Solve for H. And by the way, just by way of review, H is also called the altitude. The altitude. And if you were to look at a triangle, if this were the base, this would be the height, the altitude of the triangle. And altitude is perpendicular to the base. It goes to the opposite vertex. Perpendicular to the base and goes to the opposite vertex. All right, that's just a little aside, just throwing in something that we can think about. Okay, so here on our problem, we want to solve for the H. Okay, so the height is on the right-hand side, so we have to move everything from the right to the left. And so really all we have are things multiplied times the variable, right? We've got this 1/2 B times our H. Hey, this is not a problem. This is not a problem. Things multiplied times the variable will move by multiplying both sides by the reciprocal. So I'm going to show that here in the next step. So let me rewrite what we have. 1/2 BH. On the right hand side, I need to multiply by a 2 on the top and a B on the bottom. Right? Isn't that the reciprocal of this? Right? What do you have on the bottom? A 2. What do you have on the top? A B. So I have to do the reciprocal. 2 over B. Whatever I do on the right side, I have to do the same thing on the left. A 2 over B. So again, if you look on the right side, the 2's divide out and the B's divide out. And sure enough, our height is isolated all by itself. What's the top? 2 times the area divided by the base. And there's the formula for the height or the altitude. Okay. Let's do one more. Maybe two more. Two more. We'll use the same formula a couple times here. Number 5. How about this? 3n plus 2z equals an minus 9z. Okay, so this is a little bit different kind of a situation, and that equals an. So I just want to be clear here. I'm going to draw that a little bit more clearly. An minus 9z. All right, we have two different variables, and the first time, let's go ahead and solve for z. Solve for z. When you take a look at z, you notice you have negative 9z's on the right, positive 2z's on the left. This should take you back to the kinds of equations we solved where we have variables, the variables on both sides of the equal sign. What are we supposed to do? We're supposed to move all the variables to one side. So remember, we have a choice. We can take the 2z and move them to the right, or we can take the negative 9z's and move them to the left. Again, you know me, I always like to move the things that will end up causing the variable to be positive. So I'm going to take the negative 9z and move it to the left. How do I do that? On the right hand side, I'm going to add its opposite, right? Positive 9z. On the left hand side of the equal sign, I got to add the same thing, a positive 9z. All right, let's see where we're at. Left hand side, 3n plus, what are you thinking? All right, 11z equals an. Okay. Now, here's our variable. Now we want to isolate it, so we're going to move everything from the left to the right. What do we have to move? We have a 3n we have to move, and we have an 11. When things are both added to and multiplied times a variable, what do you move first? Things added. How do you move things added? You add their opposite. I'm going to add a negative 3n to both sides, negative 3n. Okay, my right side ends up with 11z equals. Now, these look like terms. There's a of the n's and a negative 3 of the n's. The only problem is you can't add an a and a negative 3. So this is going to have to stay an minus 3n. There's nothing else you can do with that besides factor it, and we don't want to do that. Okay, so again, we're isolating our z. All that's left is the 11. Again, we can do the shortcut. Let's divide both sides by 11. Our 11's divide out on the left, leaving z isolated, and our right side is an minus 3n over 11. And we solve for z. Okay, we solve for z. Let's take the same problem. Whoops. Let's take that same problem. Whoa, okay. All right. I love it when it does that. Let's take the same problem. I'm going to do this one in black. And let's solve for n. Solve for n. Okay, so now we're here. 3n plus 2z equals an minus 9z. Now we want to solve for n. Okay, so what are we going to do with this one? We have to move the 2z to the other side. All right, so let's go ahead and move the, let's get our variables all on the same side. So we have n's on both sides, so let's add a negative an to the right. Whatever I do to one side, have to do to the other side. Here's that same situation, right, where I can't add these up. So this ends up being a 3n minus an an plus our 2z equals, be careful now, a negative 9z. Don't lose your negative sign. Negative 9z. Okay, let's go ahead and move the things added to the variable. Let's add a negative 2z to both sides. All right, what does my left look like? 3n minus an equals. All right, what do you get on the right? I hope you're thinking a negative 11z, right? A negative 9 of them and 2 more negatives of them leaves you 11 negatives of them, right? Negative 11z. All right, so here's where we're at right now. I've got an n and I've got another n. And my problem is I can't add a 3 and a negative a. Can't do that. However, there is something that we can do. All right, I'm going to get rid of this because I need the space. Let me just bring it down here. So I'm going to leave it in my notes. Okay. All right, so let's just take a look at this situation right here. Let me get some color here for you. Let's look at just the 3n minus the an, right? That's what we have to deal with right now. So I want to go off to the right here, and I want to give you an analogy. I want to remind you of the distributive property. Okay, so let's suppose we had something like this. Let's suppose I had n times the quantity 3 minus a, and I wanted to distribute. I would go n times 3 equals 3n, and I would go n times negative a equals negative an, right? Wouldn't that be doing the distributive property? And remember then, so this equals this. Oh, got one of those arrows. Let's see if we can avoid that. I don't think I can. That's fine. Right, so this is where we end up. Right? They're equal. And because they're equal, they can be substituted. So in our problem, we have this, right? Right? We can write this. That's tricky, I know. And we're going to get into factoring a lot this year, and it'll make more sense when we factor. But that's what we're doing right now. So what does our 3n minus an become? And n times the quantity 3 minus a. We're doing the distributive property in reverse. Equals negative 11z. Why did we do that? Well, look, now here's our n. Here is something multiplied times the variable. How do we move it? By multiplying both sides by the reciprocal. Again, you could do the shortcut and divide by it. 3 minus a. We're going to divide the left by 3 minus a. We're going to divide the right by 3 minus a. What happens? Anything divided by itself is 1, right? N equals negative 11z divided by 3 minus a. Now, I understand that's a little tricky. And the key is this move right here, where we do factoring, right? We do the distributive property in reverse. We go from the 3n minus an to n times the quantity 3 minus a. Okay? Once we do that, we're able to isolate our variable, and we're able to finish, and we're able to solve. All right, that's the literal equations. Don't let them scare you. They're not a big deal. You're still going to do the same thing. You're going to what? Isolate the variable. What does that mean? Get it all by itself on one side of the equal sign. How are you going to do that? Well, things added to the variable are moved first by adding their opposite to both sides. Things multiplied times the variable are moved by multiplying both sides by the reciprocal, or in a lot of these cases, use the shortcut and divide both sides by it. Hey, that's it. Hope you have a great night, and see you in class to work the homework over this section.